Hello everyone and welcome. My name is Magdi Hanna with IIST and I will be your moderator for today's webinar on using Selenium with artificial intelligence to generate automated tests by Trevor Chandler. We're excited that you are able to join us today in this free webinar and take an hour of your busy time to be with us. This webinar is one of the series of webinars by IIST, the leader in education-based certifications and training. Please make sure to join us in the next webinar on managing user stories for effective development and testing on October 11 from 11 to 12 Central Standard Time. During this webinar, you can ask your questions anytime by clicking on the questions tab on your control panel. And at the end of the webinar, the speaker will try to answer as many questions as he can. For now, I'd like to turn the webinar to our webinar speaker today, Trevor Chandler. Trevor?
Hi. Hello, everybody. Today is going to be a very special kind of webinar. Not only are we going to talk about how to use Selenium to generate automated scripts, but we're going to give a basic education of artificial intelligence, talk about the different types and where we are. And one of the goals we have is for everybody not only to see and get an understanding of how to use Selenium with artificial intelligence, but to see a deeper meaning inside of QA in general and some of the opportunities that QA brings us as QA engineers. We have some very special skills as QA that are very relevant with artificial intelligence and where the future of engineering is going. Those are all very exciting, and I expect that this will be a mind-opening experience for everybody involved. So the presentation will be available afterwards at the Institute site. So we will be, the first slide just talks about what I said. We're going to talk about artificial intelligence, the opportunities it gives us. If we have enough time, I'm going to show you guys some very special types of diagrams for test coverage, and we'll talk about what reverse code coverage is, but that's a secondary topic. And if we don't have time, you guys can catch it in the presentation afterwards. So let's get started. So we're going to start by understanding artificial intelligence. Now, artificial intelligence is a moving term. It's not something that always means the same thing. And different people have different opinions of exactly what it is. That being said, there are certain aspects of artificial intelligence that are the same and very important components. Neural networks are probably the most important basis of artificial intelligence. And we're going to be covering those in great detail. So you will understand what a neural network is, why it's important, and what it does. So in the world of artificial intelligence, there is an accepted measurement of where we are globally in artificial intelligence, and they break it down into 3 levels. The first one, where we are now, is called artificial narrow intelligence. Narrow AI is the ability for the computer to do a very simple thing or a single thing, like playing chess or avoiding an obstacle or other things of that nature. So Google's translation engine, for example, is a form of narrow artificial intelligence. Image recognition, narrow intelligence. Now, the next stage is called general intelligence. There are actually multiple meanings to this stage of artificial intelligence. One of them is what you see here, is when artificial intelligence can understand and reason its environment as a human would. Now, some people say this is going to be 20 years away. Some people say it's going to be 50 years away. But everybody agrees eventually we will reach this. Now, the other definition of general intelligence is when the artificial intelligence has knocked out everything to do with a broad topic. So general AI for self-driving cars would be a car that can drive, it can avoid obstacles, it can turn, it knows all the mechanics of the car, it can drive in different styles of driving. Everything that a human would do, when the AI can handle multiple aspects of a broad topic, that's the second definition of general AI. And interestingly, the people that say that general AI is closer seem to be the people that want it to be closer. And the people that say it's 50 years down the road tend to be the people that don't support AI as broadly. It's probably partially psychological. Now, the third level is artificial superintelligence. And this is very interesting. This is where the artificial intelligence surpasses the human being, and it can reason anything that a human can, and it can do it better. And it's interesting. One of the widely accepted comments here is by a guy named Nick Bostrom, who I don't know how many of you people have heard, but he is the originator of what's called the simulation theory, that we live in a simulated universe like the Matrix or something of that nature. So that's pretty interesting. Some people believe that super AI is 60, 70 years away. Some people believe it's 200 years away. And some people believe that it will never be achieved. So personally, I never say never. So I think it probably will happen at some point, but there's mixed opinions. Now let's get into the main component of artificial intelligence. There are a lot of highly valuable components and algorithms in artificial intelligence, but the one in particular that seems to drive most of the newer features and the innovation is called a neural network. Now, the neural network has some distinct advantages in dealing with information, and we're going to talk about that. Now, to set the record straight, the neural network is designed after the human brain, but it's not completely designed. It's not meant to replicate multiple parts of the brain or anything like this. It models one very basic behavior of the brain, and that is the ability to have multiple little points that hold information and be able to have all those connected to all the other little points of information. On the right-hand side, what you're seeing is a part of the brain showing some electronic communication between neurons. So in the brain, you have your neurons, you have the dendrites and axioms, and those are the main components that that give you the capability to send electrical impulses across your brain. But it is very interesting that you can clearly see that many of these neurons, the circular structures, are connected to many other neurons. So in those regards, the neural network is an exact match. And that's one of the advantages of the neural network. The other advantage is a speed advantage. So in a neural network, every little piece only holds two pieces of information. They hold a single piece of data and a score, a confidence score called a weight between 0 and 1. And this score is relevant to the data that the piece of data is holding. It's how confident it feels that the information it's holding is correct. So every neuron are running these calculations and updating their own confidence score based on the results they get. But because of the way all the points are connected to all the other points, constantly what is happening here is every little piece in here is running a calculation. They're getting an answer, and then they're sending that answer to every other point of data. They're saying, look, I just did this, and this is the result that I received. And that's not just one node sending it to all the others. Every single node is sending the information to all the other nodes. So you can understand how much faster that is than, let's say, if we compare it to a standard database where we have to look up a result, and it may be in a traditional structured database, it may be very, very close in the index of the database. It may be very far at the end. But imagine in a traditional database trying to do this many queries of data. This would be the equivalent of having every column in your database send updates to every other column all at the same time, nonstop. It wouldn't happen. So now you can see the likeness of the brain, and you can see the advantages that gives us as an intelligent data structure. Now, this is just a larger picture. It's actually a picture from MIT, and you can see a much larger section of the brain. And what they're saying they've done here is they could take a snapshot of the communication of the brain at any given time. So it's very interesting, much in the same way that we run code coverage on unit tests or API tests or other things of that nature. And we can capture a snapshot of every conditional branch and line of code that was used. That we have the technology to do that same kind of thing with the brain. So they exercise a thought or a series of thoughts, and they could pull out a mapping of what electrical impulses have been sent. So it's very interesting that we have these parallels between new biotechnology and our coding structures. So now what we're going to get into is reinforcement learning. This is the scary part. A lot of people are very scared of artificial intelligence. Most of them don't really know why they're scared of it. They just know that a lot of people have said that it's scary. But if there's any single part of artificial intelligence that is scary, it's reinforcement learning. And some people say that artificial intelligence, superintelligence, and reinforcement learning, those will be the last inventions we make as a species. And I personally don't believe that, but that is an opinion of a few people. So reinforcement learning is the ability to solve problems and find answers. But the answers, there's a fulfillment of requirements that needs to happen. If you meet the criteria, which we are going to talk about, then you can solve your problem using reinforcement learning. And a summary of reinforcement learning is the computer with an objective executing measurable actions until they reach an objective by exercising different combinations and different data and different techniques with your actions. And we're going to get into some very specific examples, and everybody will understand what it takes to solve a problem with reinforcement learning, and they will have a very clear idea of that. That's one of the main objectives. So we're starting at a fantastic tutorial. It's called the frozen lake example. And in this case, reinforcement learning is used to have a person find the best way to retrieve their Frisbee on a frozen lake and not fall into any holes. So we have an objective, find the Frisbee. We have a measurable state. Those are our coordinates on this grid. We have actions, which are move right, left, up, down. And then we have some special details of certain coordinates that are a hole in the ice. Now, based on the action and the measurement of the new state, somebody moves. Did they move to a hole? Did they move to the Frisbee? Did they move to a safe area? Reward is assigned. The more impactful towards the objective the action was, the more reward is assigned. And the more detrimental, the bad things that happen that take us further away from the objective, those will subtract reward. And that's basically reinforcement learning once again. Some examples, reinforcement learning, self-driving cars, navigating through a maze, or filling out a form on a website. And that's very important because to the eyes of the computer, all of these are the same. There is no difference. And that is one of the main understandings that everybody on the call is going to get during this meeting. Not only will you understand how to go and start with Selenium and generate automation, more importantly, you will understand exactly what you are doing before you attempt to do it, and you'll be able to think about the artificial intelligence and comprehend, allowing you to move forward and not just create tests with Selenium. You'll be able to use any testing library you want. So the aspects of reinforcement learning, we've touched on them briefly. State is the first one. State is basically the observation and information that we receive from the environment. In the case of the frozen lake, it's a two-dimensional grid. In the case of a web application form, it's the interactable web elements and the location of the page. Actions are just that. An action can be moving in certain directions through a maze, or actions can be filling in a text field, checking a checkbox, clicking a link, pressing a button. All of these are the same. They're all actions. And it's important to remember, in the eyes of the computer, there is no difference. They're all instructions. Rewards. So basically, the frozen lake has a simplified reward system. So in this case, reward tells the agent, the entity that was performing actions, if the action was correct or not. And in this example, they give a +1 if it reaches the Frisbee, or a -1 if they fall into a hole, and everything else is considered a neutral. This is actually highly simplistic. It's not a very good example because in reality, the kinds of problems that we want to solve and that most people solve, there are many steps on the way that are of value and worthy of having a reward score. And how I think about it when I do web testing with artificial intelligence is I break it up into micro, minor, and major objectives. And each of those have a different amount of score. So let's pretend we had a web app that was 2 pages, and on each page, they each had a form. Once the form was properly filled in, a link appeared, and we were able to move from the first page to the second page and click to find a link on the second page, resulting in our objective being achieved. So in that case, every web element in the form that gets a valid answer gets a micro score, let's just say +1. Every time the full page is proper and we're able to advance to a new page, it's a major goal, we'll give it, 5 points. And every time we get past multiple pages and we perform the final objective, let's say we'll give it 10 points. So that is far more realistic, and you can break it down any way you want. The time that we assign reward is in our assertions. In fact, I make an assertion helper method that takes in my expected value, the actual value, a failure message, and then the amount of reward if it passes, comma, the amount of penalty if it fails. And we'll talk about some of these things in more detail. Now, there are two ways you can run your reinforcement learning, two main ways. It's wide open, you can do whatever you want, but the two major ways that it's usually done, the most common is the reinforcement learning tries all combinations, cycling all data. So that is the standard way. And the reason why people do that is because then they not only understand all the ways to achieve the objective and all the ways that don't work, but they prove without any doubt that the way that they solve the objective, they know which one is the best way. And the best way is generally the objective that took the least amount of steps. So that's one way you can run your reinforcement learning. And that's what scientists, research and development, that's what they would do. However, in QA, we may want to do that the first time as we're learning, as the code is discovering all the functionality of the application. But after that, we just want to use the best way, usually. So after the system runs, a neural network is populated with all of the information. That neural network, in essence, is a super user of your application. So you can do some very impressive things with it. You can tell it to run back all the tests using the most efficient way to solve each objective. You could tell it to run all the positive, every different way that the objective succeeded and none of the negative ways. You could tell it to run all the ways that failed. Or you can even pick a single thing and say, hey, for example, let's say we're working on a loan origination application. Somebody's applying for a home loan and they're sitting there in front of the loan servicer person. And the loan person knows that they want this person to be qualified for a 30-year FHA loan at 5% interest rate, whatever. Instead of the process of getting their profile, typing everything in, going through underwriting, talking to their creditors, all of these types of actions, the neural network has already discovered those different paths. So now the loan originator can use this neural network, which is an artifact of the training and generation of our tests. So totally separate from the fact that we were able to generate our tests automatically without coding. We now also have an artifact that is the equivalent of a super user that we can use for all kinds of methods of convenience. We may use it in QA for quality purposes. However, the user in the field, the product client, whoever owns the product and its users, they could leverage the same thing for methods of convenience. So for the first time, and this is a game changer in quality assurance, because for the first time ever, we are going from a place where we're always a cost center. We save money, we save tons of money, and we save companies from massive quality emergencies. So in one sense, we do. We save a lot of money, we save a lot of heartache. But with this kind of technology, QA for the first time, if they choose, can actually produce things that can directly generate revenue because they add great value to the application under test. Now, I understand that is very controversial to even say, because it's something that we've never done before. We never talked about it before. But as the quality engineering community, it's up to us to think of those things and to bring innovation in. Just like we made automation and software wide scale, just like we've invented different types of testing and different techniques. Now, with artificial intelligence, we have this opportunity to move forward and raise the bar of what we do further than it's ever been into areas that may have never been considered. So remember, as a QA engineer with artificial intelligence and your process skills for QA, which are crucial, you have to have those. Those together make an incredible combination that will bring QA into a future where not only do we assure quality, but we bring innovation in ways that have never been considered before. Here's an example of the frozen lake with reward assignment. Now, as we talked about this one, it's very simplistic. You could see that no reward was assigned in this iteration, except for the final when they found the Frisbee. And this appears to be the single iteration. This looks like it was the final iteration where they validated the least amount of steps to hit the objective. But still, we have an objective, which is to get to coordinate 3_2, in other words, get to the Frisbee. We have our actions, we have our measurable state, and our reward. So we have all the information. Those are the requirements that we need to fulfill reinforcement learning. So we've talked about some of this, but just to retouch, reinforcement learning can solve a huge variety of problems, achieve a massive amount of objectives, if your criteria can meet the requirements. The objective must have measurable actions, and we measure them with our assertions that are reasonably believed in some combination to be able to fulfill the objective. Now, this is important, reasonably believed. We don't know if it's going to solve it or not. If we did, we'd already know the answer and we wouldn't have to run the reinforcement learning at all. But you want to reasonably believe. So in the case of the frozen lake, because we're in a two-dimensional grid, and because we move from square to square, and we have the ability to move in all directions, and the objective, finding the Frisbee, obviously can be achieved by some combination of directional actions, we fulfill that requirement. Now, for a web application, it would be different. It would be the entering text, getting text from labels, waiting for components to appear. Things of that nature are the actions that we believe in some combination will fulfill our objective, as well as having the right test data. The actions must be executable automatically through a system that also has access to the results and can persist and update the persisted information. We're doing it on a computer, but self-driving cars, robots, there's a lot of other types of devices, smartphones, that have artificial intelligence and they meet the same criteria. And not everything has to be on the same system either. You can have a distributed artificially intelligent system, let's say, that communicate to each other through web services. You might have a computer, a series of sensors, and then some objects of interest and a robot arm. So there's a lot of different combinations that you can do to achieve this. Okay, now this is an article on LinkedIn that you can read if you want. It goes into extreme detail of the two different types of reinforcement learning. And it actually tells you how to set up your page objects and things of that nature in Selenium. Now, saying your test automation is completely obsolete is obviously a controversial statement. The statement isn't to downgrade anybody's automation in any way. Basically, it's I'd like it to be perceived as a gentle push that is quality assurance. We don't have to continue to do the same things. We can look at other technologies, and we can even be the first. We can look at new technologies and find new ways to use them and bring them into our industry. We don't have to use things that aren't useful, and we don't have to use new things either if they're not. So this is really it's actually a very insightful and kind article. So there's no disrespect meant here. It's just really to remind you that we can push forward, we can create new things. I'm sure many of you remember the time before automation became popular and manual testing that's what we had. And I remember back in the late 80s, we started having tools like WinRunner and XRunner. And those tools back then had analog modes, so you really had coordinate-based automation. We've come such a long way since then. So this article is a reminder that we can continue to do that, but only if it's useful. We don't want to move to a technology just for the sake of using new technology. We want to use the new technology only if it's useful. And what's useful to one person's test approach may not be useful to another person's. So there's an aha moment, and this is probably the single most important thing to grasp, because if you grasp what we're talking about on this slide, you will be able to self-direct your journey, your adventure into artificial intelligence to see what it can do for you. In the frozen lake example, our environment was a map. It was a grid. There were actions we could take allowing us to walk in different directions. We could measure the results of our actions by recording which coordinate we were located on. And if our location matched the final position, then we could assign the reward appropriate for finding the goal. Now, I'm sure everybody understands that. The mouse in the maze, basically. Now compare that in your mind, in your bubble of thoughts, to this. In a web application under test, our environment is defined by the web elements, links, and the pages we are on. The actions we can take are things like entering text into a field or clicking a link, and we measure the results through assertions on elements and what page we are on. So those things are the same. There's no difference between those two in the eyes of the computer. And that's the most important thing to realize. The most important tool that we all have is our brains, our minds, our ability to symbolize, our ability to put meaning to a process or an idea. And in this case, my hope is that everybody will have a new process in their mind that says, I might want to look at artificial intelligence if I have a problem that has measurable actions that are reasonably believed to achieve the objective that I'm trying to solve. And if I have those things, that's a technology I may want to consider. And it may be navigating a maze. It may be balancing two objects on each other. It may be driving a car. It may be testing a web application. And that all those things are the same in the eyes of the computer. That is the single most important thing to get out of this. Now, we have a rich future as quality engineers. Our industry is going to drive so many advances and discoveries that it's going to be a shock. And there's two real main reasons why this is the case. And here's one of them. So a developer creates things for people to use. So developer creates things that people are going to use. It seems obvious, right? Everybody knows that, right? But a quality engineer creates things that act like people doing things. So developers create things that people use, but where we specialize is creating things that act like people doing things. What does that mean? In other words, we create actions. And what is the criteria for solving a problem with reinforcement learning? Measurable actions. So now you understand, we happen to be in quality assurance, and we happen to use certain techniques. But in the context of artificial intelligence, it won't matter if it's testing an automated form or if it's trying different combinations of proteins to make a more powerful treatment or a cure for a disease, or architecture, making sure structures are sound, all of these types of things. We are experts in simulation and simulating actions. So our obvious evolution is to be empowered by being the ones that take reinforcement learning forward. That's a huge advance for us. And I know this is probably strange. It might even freak some QA people out to hear this. And I encourage people to think on their own. Some people may not see this in the same way as I do. However, I strongly believe that this is the case. And I hope that this fact inspires each of you to realize that you can do so many things. I'm not saying that everybody should go out and try to do everything. What I am saying is that everybody should be empowered to realize the capabilities and go after the things you want to do. Be empowered by this and be excited. Okay, now I'm going to show you guys some video, because I don't believe in anything without evidence myself, and I encourage the people on the call to not take anybody's word for something. Investigate the evidence. After all, that's one of the main things we do in our career. So let's okay. So let's get started with this little video shows some of the source code. Okay, by the way, this isn't any kind of product. This is our own little lightweight wrapper that we made around our artificial intelligent functionality. So let's skip along here to something. Okay, so let's just get right down to business here. Okay, here we go. Okay, this first example, what you're going to see here in a second, is every numeric field only has one correct number between 1 and 100. The artificial intelligence is going in and varying the data, and it's doing it quite quickly. So you'll notice that some of the boxes turn green. When they turn green, it means we found the proper number for that field. However, you'll notice that even after they turned green, they often went back to red, the wrong number. The reason for this is we're testing all combinations and not stopping after we get the right one. So we talked about the two modes of reinforcement learning, trying all possible combinations versus taking the first objective and going forward. So there you see integers. You see us going through multiple forms. Let's take a look at, Okay, so this is not the code one. Let's take a look at the code one. Okay, great. So using Visual Studio here, and Visual Studio has a free version, Visual Studio Express. It's the Python programming language. And we use Selenium with the Python language bindings. Now, this is an important note because just checking the time here, making sure we don't. Okay, good. So this is an important distinction because generally, and my company, we've done over 150 automation projects over the last 8 years, pretty much almost one a month, nonstop. So, you know, we use these tools quite often. And the general rule of thumb that we like to follow is you look at the application that's being used in the application under test. You look at that, whatever the language is there. If language bindings in Selenium exist, you use the same ones. So you have synergy with the developers. So the developers can help the QA if they need help with more advanced design or coding or whatever. That's the rule of thumb. But with artificial intelligence, we specifically use Python because Python is the language of AI. For some reason, that's the language that supports all of the best artificial intelligence libraries. So the AI libraries themselves are highly optimized C++ and C code generally. And the Python is just what they call a language binding. So it lets the Python code bind to function and method calls of the C++ and C. So you don't have to touch those languages. You can do it all through Python. So let's go through some examples here. This one, we're going to be dealing with text values inside of multiple page forms. So you can see it did a really quick iteration there. Now, this is purposely recorded this way to point out a very specific problem. Did you guys notice how long it took for that UI page to load up and enter? It probably took a second, and a second is too long. We can't wait that long. That was one of the major problems with artificial intelligence and UI testing. That you have to be able to run it a large amount of times. And it wasn't until June of 2017 that a very special event happened. Google came out with the world's first lightweight artificial intelligent model meant for mobile devices. There had been some before, but they were very laggy, very inaccurate. But Google created one that ran with a very high frame rate, and it was detecting multiple. It was a famous image in AI now. It's a picture of a beach with a bunch of people at different distances flying kites. And there's about 18 objects, 9 people, 9 kites. And this model was able in real time to detect and track with accuracy in the high 90 percentile. So that was a landmark occasion. So that basically it solved one of the problems, the problem of having a model that could run fast enough. Now, we still have the speed problem of the user interface, and that was solved in multiple ways. The first way was headless mode. So we solved it by having a headless mode in browsers. Firefox was one of the first to do it, if not the first. And your tests running in a headless mode on these browsers, the browser won't instantiate. So when the browser gets its information from a web server, it stores all that information in what's called the DOM, DOM, the document object model. It's a hierarchical representation of all the information that came from the web server. So in that state, headless mode of a browser will test directly against that server information. And this can be 10 to hundreds of times faster. If you write your tests in a very specific way geared towards optimization, you can run your web tests as fast as unit tests. So now we have this increased ability to run against the browsers in these headless modes. So between that and the artificially intelligent model being highly increased, we solved the problem. That was the first time that we could actually even consider using artificial intelligence for UI automation. Now, furthermore, the artificial intelligence can run on graphic coprocessors called CUDA cores. So when you get an NVIDIA-style graphics card, they have these little tiny processors on them called CUDA cores. They're not anywhere near as powerful as a processor for a computer, but they're specialized for math operations, specifically 2D and 3D. And artificial intelligence, those are some of the main calculations that are made. So these graphics cards, let's say you spend $300 and you get an RTX 2070. There's 2,000 CUDA cores on that card. And the neural network can take each of its points of data and spread them across the CUDA cores. So now on your graphics card, you're running 2,000 pieces of your neural network at the same time on their own processors. That is a huge increase. Not to mention, we can use multi-threading. We can balance across cores, and we can cluster across machines. So now we have the parallel means to run to really increase that speed in multiple ways. I'm sure probably most of you have set up automation inside of continuous integration like Jenkins or Anthill or Cruise Control or whatever. So it's the same idea. We use those same techniques. We can actually even use the same tools if we want. So it's really wide open. A lot of this is possible, and you can do it in many different ways. So let's go ahead and to try to rush through this to give as much time for questions as we can. Okay, so that's the gist of it, basically. If you guys reach out, send an email to info@Testing Institute. I'll send you guys the code so you guys can get started. And the article on LinkedIn will walk you through how to set up your page objects. And like I said, feel free to ask questions, send comments, or whatever you want. And it looks like we're going to have 11 minutes to take questions. So let's go ahead and do that now.
All right. I am looking at questions here. I don't see questions at this time, but anyone, please, if you have any question, this is a lot of information that Trevor has presented. I've been watching this, and it's very interesting. I understand that 1 hour is never enough for all this stuff. That's why I'm going to try to speak with Trevor to try to convince him to do a 1 day or 2 day course, whatever he sees right. If that's possible. If you are interested in seeing 1 day course at least being done online in the same fashion, go ahead and just to give us your opinion, either by putting a note here on the questions tab or sending an email to info@testinginstitute.com. I see a question here from Jyoti saying, what courses would you recommend to automation testers to start with AI?
So I would recommend first that you do a basic Python tutorial, so you have a basic understanding, since that is the most popular language. The second thing I would do is the frozen lake example. Now that you understand the correlations between the reinforcement learning and solving a maze, and how that's the same thing as interacting with a web form, the frozen lake will teach you fantastically. Also, if you don't understand what page object design pattern is or page factory, then those are things that you're going to want to understand before you start this. Those are design patterns for Selenium or other tools like it that reduce they make the tests easy to maintain, basically.
Okay, I have another question here from Corky. Says, did you mention the tools used as a list for creating an automation center of excellence? Do you follow this question?
Well, I would say, well, we need our IDE. So there's a lot of things that can go either way. You need your IDE, so either Visual Studio Express, which is free, or that's probably the best bet to go these days. As far as tools, the Selenium libraries, the TensorFlow. By the way, TensorFlow was the tool. It's by Google. It's what I used, and that's what I prefer. But there are other ones like OpenAI and PyTorch that are also very popular. So I would start. Those are the three applications that you would need to have, in addition to your normal QA stuff. You know, your bug tracking, your test case repository. Those are the immediate ones.
There's another related question. Could you please mention the tools and software needed to work on the code you mentioned you could send?
Yes, absolutely. And you know, I'm going to make before this gets uploaded, I'll send a new version, a list of tests used. I'll clean it up and put it in the deck in an appendix. But basically, TensorFlow, Visual Studio, can be Express. You need a Python 3.6.x or greater. You're going to want, you can use Visual Studio, or a lot of people use PyCharm IDE, which is a little more basic. Convolutional. These two things are not tools, but they're components that you're going to want to get familiar with. Convnets, recurrent nets. And I'll put some more together, but really, and then Selenium plus Python language bindings. And if you really want accelerated speed, get a CUDA core compatible card of CUDA compute level 3 or greater. Okay, I'll get a more complete list here and include it in the presentation that you can get from the IIST website. But these would be the main things to get you started.
All right, another question here says, I heard about 2D and the 3D calculations, and I work for an engineering company where we need to create design models. Could the course you had mentioned work? Again, the question is, yes, you want to create design models.
Yes, well, for that, probably the best kind of tutorial for you is going to be, say, training tutorials. So for that, you're going to want to do a tutorial, and TensorFlow has a fantastic, in fact, there's two I'll mention. TensorFlow's ConvNet training. A ConvNet is a convolutional neural network. That's a special type of neural network whose data points hold pixel features. A pixel feature is a group of pixels. So it's little parts of images. So when you're dealing with designing and whatnot, it has to do with real objects like engineering, CAD and things of that nature. The ConvNet is going to be your best bet to start. And the other one is, it's on YouTube. You're going to want to look under TensorFlow, training your own data set, macaroni and cheese. They use a macaroni and cheese as the object that they're building a training library for. So these two are going to be the best to use. And we absolutely will be making a thorough training for IIST, and it will include everything. It will walk through all the tools. You'll do basic tutorials in each one, and you'll write tests, and you'll run them and everything. So keep an eye out for that at IIST. In the meantime, these are some excellent resources.
I'm seeing only one person who expressed interest in the course. So if any one of you think that a course would be, or you would be interested in the course, just let us know so that we know the level of interest. Right. I have another question here. We've got only 3 minutes left. Is this methodology applicable to back-end testing?
Absolutely. In fact, back-end testing, it was possible to do this much earlier in time, because you didn't have the same speed problem. So for unit testing, your environment is your package or namespace structure, your methods, your objects. So that becomes your environment. Your asserts are still done through asserts, and reward is still assigned through assertions. And for API testing, your environment is modeled after the schema. So you'll iterate your schema to make sure you don't miss any parameters or types of parameters. And same thing, your response asserts will be where you check measurable state and assign reward. Also, your action set is going to be, in unit testing, your actions are going to be things like instantiating a specific object, calling a method. In API testing, your actions are going to be doing an HTTP post, doing a get, etc. Things of those, doing HTTPS. Those would be the different action sets. So absolutely possible, and will actually be much faster, even in headless mode, compared to UI.
Okay. Quick here, we have 1 minute left, and we'll see if you're willing to stay a few minutes beyond our time. Question says, can you recommend tools or libraries for using AI with implementation in Java?
In Java, that's a really good question. I have to be honest with you, there probably is one, but all the popular ones are AI. So I haven't even attempted to do that in Java. Undoubtedly, there is artificial intelligence support in Java, no doubt about it. And Java has what's called it's JNI, Java Native Interface. That is the equivalent of doing like a binding Python to a C++ library, language binding. That's Java's equivalent. So look for TensorFlow JNI or PyTorch or OpenAI JNI, Java Native Interface, and those should get you finding what you need. If not, you can make your own.
If you're willing to go for a couple minutes, you have a question here. You mentioned getting to know page object model and something else. Can you re-mention that? What else besides page object?
The second one is called page factories. Now, I got to be honest, this is my own opinion, so it doesn't mean it's right or wrong. Page object is basically one page, one class, one organization of code, one class represents one page in your website. And all your locators, these are the information about your web elements that you use to look them up and get a hold of them in Selenium. Those go on that page only. And then your methods to use things on that page go in that same class. So that's page objects. So if something changes in the UI, you only have to go to one place to fix all your methods and your locators. Now, 95% of people use page objects. Page factory is a different approach. Maybe 5% of people use that. And what they do is they have this initialization method. When you load a page, you automatically load all the objects, whether you're going to use them or not. And it does an extra amount of validation because you're making sure all your objects are actually there and in the right are active. I don't like it because you constantly use more and more memory, and I don't like to be inefficient, but it does have its advantages. So those are the two accepted design patterns in Selenium and other library-based tools, and the one you guys choose is up to you.
All right. I am going to wrap up here. By the way, again, as Trevor mentioned, this webinar is being recorded and will be available at the Testing Institute website early next week. So you should see all those questions and the answers that Trevor has given. Trevor, I want to thank you so much for your time. I know how busy you are. And thanks for allowing us to share your experience and your knowledge with the audience. Certainly, we need more time with you for people to learn more. Thanks to everyone for joining us today, and we hope to see you in future webinars by International Institute for Software Testing. Trevor, thank you again very much.
Thanks, everybody. Have a great day.
Thank you.